Thank you. So just brief logistics. As you self-selected to be mostly on this side, and I have one pointer and limited ability to coordinate two different arms, then I will point primarily here. Hopefully this won't be a problem. Things are highlighted in the slide, and then we can move forward. So thank you for choosing to be here at this conference and in this room. The other talk looked interesting as well, so I appreciate that you're attending this one. So I'm Claudio. I work at this point in time as PDFKit, and I work primarily on a Elixir code base that is really side effect rich. Like for context, the application I'm working on deals with a database and deals with a proprietary daemon that manipulates PDF files, writes to the file system, writes to caches, does a lot of stuff. Turns out that working with PDF files is not trivial, and so you kind of have to have different layers for everything in terms of optimization, performance, and compatibility with different layers. And so the code you write is very rich of side effects. And we heard before from the keynote that programming in the real world has to be useful. This kind of stuff is incredibly useful, but it comes at a price that is around complexity. I currently live in Turkey, and it's incredibly difficult to find that specific cake, which is a Christmas cake, which is a big deal for me. So I'm now saying it's possible, but it costed me the equivalent of 15 euros compared to 2 euros in Italy. So just as a colorful note. So why are we talking about this in the first place? Because side effects are sort of like the sauce that make our programs do things that people actually appreciate about them. But they're also one of the primary sources of complexity. And this comes without a value judgment on any of that. It's just that they require a strategy on our end to be to make sure that we can handle them without getting frustrated. The main properties that make them complicated, and it's just worth reiterating them here, is that they're non-deterministic. If you talk to an external API, you don't necessarily know for certain what kind of answer you're going to get, because maybe the other side is at that point is not available, and then you may have a wide range of errors that change over time as well. It's not that if they're throwing a 401 today, they will keep throwing a 401 with the same response body, for example, next time. And so it's important to keep that in mind. Some operations are not idempotent by default, and you have to build idempotency or idempotency, not exactly sure about the pronunciation, by yourself. So, for example, if you're interacting with a service that sends emails and you don't want to send the same email twice, the code that makes that deduplication most of the times is left to you, because it turns out that deduplicating things at scale is not a trivial thing to implement, and a lot of services you interact with decide to leave that problem to you. And sometimes it's very brittle. To write tests, especially that do this. Classic example, you want to test a checkout process in an e-commerce application, you have to have a user, you have to have the product, you have to have stock, and once you finish writing all of that test setup, then you can actually write the test code that you really care about at that point in time. And because you're interacting with services that they might not be under your control, you might have performance bottlenecks. Like they can be slow, or you can be rate limited, for example, or you have for example, like they might cost you money every time you use them. And so that cost gets factored into the complexities of what you're doing. And so we'll try to stick with this specific example throughout the rest of the talk, which is a contrived example of something that you could do in an application. And you look at it, and it's almost, if you had to, tell what it does, it almost reads like a sentence. You're saying, like, if I have a reference of a user ID that maybe just signed up, I want to send a greeting email. I want to try to find a user somewhere in a data store somewhere, not trying to be not too specific about it. Could be a database, could be something else. And if you find that, prepare this email, so that the structure that represents an email, and then send it some way or another through a, I don't know, SendGrid, Mailgun, your SMTP server, whatever email delivery system you wanna have. And this code, which reads really nicely from the point of view of telling you what happens from a business logic point of view, has two sources of complexity for what we care about. First one is, how do we get the user? That could be anything from in-memory, the copy of the data, maybe a cache that you have, could be a call to a database, could be a call to an eventually consistent data store, and we saw before from the keynote that can get funny very quickly. Could be anything, so you just don't know at this point in time. So this specific function, which we just say can have two possible outcomes, turns out that it can have other outcomes that you might not be able to capture, or it might not be that you are able to capture just with the return type of it. Because if you get a connection error, and it might not just come up as a pattern matching, it might be something that gets raised as an exception and causes your process to crash. And if you choose to handle all of those things at a type level, then the compromise you would be making is having a business logic code that could potentially grow in complexity just because you have to pattern match everything. So it looks fairly contrived, but it packs a lot of extra information. And the second point is sending an email. If you ever worked with sending emails, and making sure that they get there, that's a product on its own, and there are companies that live off that because it's not simple. So when we say we send an email and we pack all of that, we sweep it under the carpet inside that function and other functions, what happens there, because we don't want to necessarily deal with the details every time, we make a conscious choice around not worrying about all the failure cases that once again might come up. But if this represents the golden path of your application, if this is a greeting email, but you can imagine that specific email could be something way more important. Suppose you got a sign-on system where you get a magic link through email. The fact that that email has to be delivered as best as you can with a certain level of confidence becomes integral to the product you're building. And so the testing around it probably requires a certain level of resilience that you have to worry about. And so how can we test this? All of these scenarios have specific strategies that we can follow. So many libraries, and the example that I'm making is so I guess I should have prefixed this. A lot of things we're talking about today, you could basically swap everything with Erlang and just write all of the examples and all the things in Erlang. There's very little that is specific about the language. Just my experience, I'm more familiar or spend more time with Elixir, and so the examples I have fresh in my mind come from libraries in Elixir. The Ecto ownership system, if you've ever used Ecto as a database library, is quite a good example of a library-specific solution that helps in this respect, particularly if it interacts with the database that supports the same level of isolation. So what you can do with tests in Ecto is decide this specific process that runs this specific test gets assigned one connection, which is owned by that process, and potentially processes connected to it, whether tied by a reference or by spawned by that process. That specific reference maps to a database transaction, if you were using a data store that allows it, for example, Postgres. And each process lives in a different transaction. So if you write the same user with the same ID in separate transactions, they don't overlap each other. And it gives you the ability to run concurrent tests with isolated state. That's a really good property, and it takes you a long way. The thing about this is that it works because it's a sort of like a combination of stars aligning that allow you to do that. And it works really well when you can do that. But if you, for example, are in a situation where you have to interact with a specific service that is a service that it's an internal service maybe that you have, or it's a legacy system, there is a concern of the amount of time and effort that you put into potentially finding a library-specific solution for that specific service. Because if it takes you 1 or 2 months to build that specific solution, that's time and money that is used just for that. And so in some cases, it becomes something that you can't afford to do, unless the payoff is that you can get that back in dividends further on through the lifetime of the product that you're working on. And so while this to me, in many cases, seems the preferential solution, most of the times in my developer life, I couldn't do it. And so I had to find like a different way. A more general way is mocks, right? You mock the layer that you're testing against. When I say mocks, I would encourage you to read both particularly the blog post on the Plataforma Tech blog, and then the corresponding library, because mocks, as defined in the scenario of those two examples, they have specific properties that leverage the strength of the runtime. In terms of, these are mocks that get defined at compile time. They get set up most of the times at compile time, so they give you compile time guarantees. You mock test by test what you need to change. The implementation code has a very minimal impact. You sprinkle some compile time attributes to sort of like switch between your implementation code in development or production versus the code in test. And it's a very solid default that you can go for. So even before talking about a different technique that I want to talk about, in general case, my recommendation would be to look into this and see if it solves your problem. If it doesn't, and there are specific reasons why it might not work for you, then you can look into alternatives and what we're going to talk about today. But most of the times, this is a very good solid default that works really well to define at compile time between test and essentially the difference between development, production, and test, two separate worlds. And every test gets that. But what you get is definitions of how your compiled code looks like. So you don't necessarily get support, for example, for dynamic references. If you want to pass around an ETS table, for example, this doesn't necessarily take you there. So you have a specific structure. So what are the goals of the thing that we're going to talk about today? Well, we want to have a unified test strategy. So the idea is that if you can't afford to have a library-specific version for everything, every state dependency that you have, then you want to have a general strategy that looks the same most of the times, so that when you open that code and you see that pattern, you know how it behaves under the hood, and then you can use that to focus only on the problem at hand, instead of having to remember the specifics for every dependency that you're using. We want to have something that is concurrent by default, where concurrency happens as a side effect of the approach used, meaning because it's written in a certain way, it happens to be concurrent as well, without doing anything explicitly to achieve that, because that would give you essentially potentially more noise or potentially more logic that you have to test on its own to guarantee that concurrency. And we want to have easier maintenance. Now, easier maintenance of test cases with a specific idea of what easier maintenance is. To me, it means if I reopen the same file 6 months from now, or I give it to someone else, that test should, as much as possible, be self-explanatory. Like this system, in the ideal world, it does not require jumping around between 3-4 different files and 3-4 contexts to understand what's happening in the test. If that's the case, then we are basically trading time, essentially, like we are stealing time from the future, from our future self, because we are basically gambling on the fact that either us or someone else will be able to understand that context quickly enough when they open that file. And the last point is, this specific approach has one specific property, which is it only works for unit tests. So you cannot use it to write system tests. And that is a design decision, because in system tests, in my opinion, they have to stress the thing the way it is. You can't really, or rather you can, but I found that sneaks in more than one bug. You stress the system the way it is, without any mocking layer, just testing the real deal. And so by doing that, by having this distinction, which is artificial, then it lets you basically define a clear boundary that you can get different levels of confidence. And most of the times, a good battery of system tests gives you very good confidence about the product as a whole. While unit tests, they give you a lot of confidence about the corner cases that you found throughout different patterns. So the strategy in a nutshell, is we're gonna start by taking these side effects, grouping them into modules, and giving them a name. That's a classic refactor pass. That's fine. We're gonna pass these modules as argument to the functions that use them, so that they become essentially parameterized throughout the functions. Then, as we start grouping them together, we're gonna put them in a data structure that tells a story about them, that gives us a good way to manage them over time. And once we get to that point and we look at the system again, then we'll see if we still need other ways to mock particular dependencies. And then by rinsing and repeating, you get to sort of like a cycle that you can reuse over time. So grouping side effects. So we got back to this one. And the first thing is, we had let's say that we are at the beginning of the project, that's the only place where you send an email. Still, it's a good thing to do to extract the send email function from a private function underneath that we didn't see before to a separate module. Because there are so many reasons why you can do that, and some of them have to go around, like, for example, solid principles, like software design principles. There's a practical implication to that. If you do that, then you can, when you move that out, then that module, the sends emails, can be tested in isolation against the real sort of like delivery mechanism, and it becomes a single block that you can maintain on its own. And if you send an email, it's not particularly apparent, but let's say you have a slightly different use case, which is, for example, like having to, it says pointing. Oh, okay, doesn't work anymore. If you have, for example, a fiction, Dropbox client, if you group things together, then you start to see potentially patterns showing up in terms of the types that you're using. And so when you upload a file and you, by name and context, you get back a path, that path as a type comes back in other functions. And work around this helps highlighting the structure of it, what this module actually does, and the boilerplate of dependencies that you have against this external system, which could be Dropbox, where the details fade into the background. Like, you don't need to know how you upload things to Dropbox. As long as you have these types that mesh together properly, that interface, which you might swap for a test, will be fine. You can go forward and introduce behaviors on top of this. That's normally, I found that it doesn't give you any drawbacks. So using behaviors aggressively in this area usually leads to even more stable interface, where you get a little bit more help by the compiler into keeping it right. But the important thing is that you focus on the return values and the types you pass on, because those are the things that you're going to have to keep track on when you write tests. And if you have that module just grouped, then you have a test for it, and then you tag it. Maybe you don't want to run this test every time. I would normally run this on CI when you get, basically, if it's your last gatekeeper before production, then maybe you want to run it, because there's a chance that you pay the price in terms of availability. You might stop production because there's an outage on Dropbox, but chances are that if there's an outage on Dropbox and your CI fails, then your production is already failing. So there's sort of like some considerations to do, but it's important that this thing gets tracked. So you might not run it on a daily basis, like certainly on your machine, maybe you won't run it, but somewhere in your delivery system, there should be a place where these tests are run regularly. And so by doing this, we get back, basically, we go from like separate functions, we go to a single unit that you reason about, that talks about the service that you're testing. So talks about that side effect as a whole and as a concept more than implementation detail. And then you test it on its own, and then that gets maintained essentially as your side effect module that talks about that thing at a specific level. So when you pass them around, if you have, for example, if you switch, instead of having them as are coded in the code, you pass them, for example, through a map. This is a specific trade-off that is making it, which means that you're trading basically help from the compiler, because you're swapping a static reference to a module through a dynamic value. So there's a concern around that, which is it wouldn't be useful to just sweep it under the carpet. But as that's an arbitrary map of things that you pass, that might include, for example, static code, like those two reference modules, and dynamic parameters. For example, it could have an ETS table reference or a counter reference that you pass on. Then you have a generic way to say these are potentially effectful things in this little context that you pass on that you need to use to execute this function. And by doing this, the code behaves absolutely identical. There's a one extra argument to the function, which is this context, which needs to be managed. But we can work around that, and we can sort of like introduce that we introduce better ways to handle it. And I hope this reads at the end. But essentially, a test file that we never sorted out coding slides. This is a standard problem everywhere. But you have a test where you can basically define just for that test, that just automatically namespaced through that test implementations that just by pattern matching, they deterministically take you to a result. This is not very different from using a mock. This just doesn't have any, like it behaves like a mock, it just doesn't have any framework around it. But you have the ability, if you wanted to, if it makes sense, you could even do this on a per test basis. The trade-off in that is that you increase verbosity for the test, but if it makes things clearer, you can definitely do it. You just need like a little bit of metaprogramming to generate module names around that. But without metaprogramming for a test that has maybe like 5 or 6 or maybe like 10 cases, pattern matching with really good names in the pattern matching could work. So in this case, example ID returns a user with a specific email. That email is pattern matched in the mailer module, and then that makes it that the function shortcuts directly to the golden path. The golden path is just because this way, just as an example, it would be more interesting to have this error in specific ways that you want to test as a outcome that you don't want to. And so this means that the test becomes essentially a test bed where you can write all of these edge cases. So we pass them, and as we have a map can be extended over times. Because it's a map, you can sort of like decide if you want to default or if you want to enforce the presence of the key. I'm calling it context, but naming things is particularly difficult. And if you use, for example, Phoenix, context is sort of like a concept that is already taken in terms of bounded context, in terms of domain-driven design. So I'm not, I'll be honest with you, I'm not exactly sure about the name because, well, most of the obvious names are already used. But conceptually, it's a bag of dependencies, except that dependencies is already taken as well. Environment is taken as well, and I don't know. I'm accepting suggestions. Where do we go from here? A map is okay, but it doesn't have stability. Like a map, it can be something that changes over time, and if you're like me and you make typos, you can introduce necessary errors just because you mistyped a key. So we can start to basically do something a little bit more strict, and we introduce a struct for it. So it has the same properties of a map. So you just use them as keys, but it has good defaults, and you can basically put the production defaults in there. That's normally what I do. I just put the actual modules and dependencies that we use in production. Have a nice way to instantiate this struct, and have a way to override them. But because we made a trade-off before around moving a static reference to a module to a dynamic reference through a map, then we want a little bit more help to the compiler, from the compiler back. So by using that notation, essentially the struct update notation, the map update notation, we make sure that we cannot make a typo. If I misspell user cache and I forget about the underscore, that notation will basically trigger at test time, at test runtime, an error says, look, you're trying to basically update a key that the struct doesn't have. It's not defined. And so at least you don't get like an unexpected result in the test. You get a more useful error. The other thing is that because that's a struct, then you can also use, for example, if you had a user cache, which I don't even know what it does at this point, but it's, let's say that we are caching data about users, you can dynamically call a function for it, for example, by leveraging the fact that a struct can call other functions. And then if you want to have a different, for example, maybe this user cache could be an ETS table. In your test, you don't want to necessarily have, you might not want to pass around code. You might pass around references to data. Then you can do that together with the context. So you get more flexibility around what these things are. You could pass essentially whatever you like in that data structure. So you can get more freedom in terms of fitting this to the domain you're working on. And if we call that function, the default function in the context, then we go back to a situation where you could potentially call send greeting just with a user ID. Let's say that you're doing this as part of potentially a production troubleshooting. That helps because you don't have to get that continuously have that with you and having to have typing every time and that extra context. So it's there, and you can sort of like get, if you don't have any options that you need to pass, it uses the default one. And we get back to having a notation that goes back to one single argument. The test looks very similar, it's just that you have a specific DSL. So you don't build the map by hand, you explicitly override specific part of it, which has the advantage that you can just override the parts that you care about. And finally, this might not work every time, so this is a sort of like again a default way to do this. It's if you have a context that you know that is not going to change throughout the lifetime of application, you can define it all the way up into the application and then pass it down. Chances are that some things might change over time depending on how the application behaves. And so having that as dynamic data means that you can potentially mix and match. You can define parts of your code based on your supervision tree that just take a context and they always work with that, from parts that could potentially have this changed and updated depending on what they're doing. For example, you might have a part of your code that switches between a read and write store to a read-only store, for example, for performance at given time, or falls back to a secondary data store if the first one misbehaves. Like you basically can do whatever you like to manage that context and just pass it around. And so these are essentially the benefit. The data structure is good. It gives you that testability. This in the beginning, especially if your project is starting, it might seem a bit overkill because there's a few moving parts, but it comes with a convention. And so the more you introduce other dependencies, the more you can sort of like move on and extend instead of having to have a ad hoc convention every time. And default values are there. And if you initialize it all the way up and pass it down, you get more stability and the same assumptions down in the code. So when you get to this point, we still need mocks as something which actually is a mock explicitly through a library. Well, sometimes you do, because essentially there are places where if you interact with a vendor API, in an ideal world you wouldn't need to use them, but you don't want to have maybe all the time a network dependency for an external service like that. Particularly if you're testing the module itself that talks to that service. And so maybe you still need an ad hoc solution for that. Popular one, which always kind of works with external APIs, is the VCR approach, or recording responses. So you hit it once, and then there is reply stored into a fixture, and for a certain amount of time, it gets replayed every time you hit the API. That's VCR is available in different languages as well, so it's not specific just for Elixir. So that usually works really well. But I still think that most of the times, unless you can actually prove that it's more of a problem, if you deploy with master, then master, as best as you can, should not record anything, because that way you have more reassurance about the actual world around your application. And the other thing about this is that we didn't talk about that because that's a separate talk, but how do we test the entire system? So that was the original premise around this, is that we would talk about testing on the unit side, but the system itself requires a different testing. If possible, you don't want to have any mocking at all. The example I can give is that the code I'm working on now gets, we don't run it on production. We sell essentially a Docker image to customers, and then they run it on their own infrastructure. And if you, I don't know how much work you've done with containers right now, but there's like so many ways that you can run them, like depending on the service provider that you use. And things can go wrong really quickly in completely different ways, especially if your application has optional components. Like you might have we have an optional caching layer, so that gives makes them more complicated. And the best test suite that we have in that respect is a test suite that basically takes the image, runs it against actual components. We don't do anything with the databases or anything, and just hit it with HTTP requests and just test that the responses are back. And when it finishes, you throw away all of the containers and all the data. So we don't leverage any form of transaction, rollback, or anything like that. We run it the way it is. And that gives the best level of confidence, because then you can run it. You want to run it on multiple nodes, you run it on multiple nodes. You want to enable optional dependency, you can do that as well. And those tests are very easy to maintain, because they're exactly the same things that customers use. And so you get the benefit of dog fooding the product, even if you don't run it on production. The other thing is, not necessarily test is the answer for everything, particularly when you want to assert facts that production has. I forgot the name of the company, but there was a company in London that I heard about a few years ago, where they were doing deliveries of items, and they continuously buy very cheap stationary items through their own system. Like a bot would do that, go through the entire checkout process and deliver them to their office every half an hour, like a pack of Post-it notes or a pack of pens, because people would always need them. But that way they had this, there was basically this bot that would just use the entire thing top to bottom continuously. And they knew at any point in time, with maximum half an hour of delay, if there was any critical problem in production. You could argue that half an hour is too much, but you can think about your business logic and think about your golden path and the critical path of your application, and you can potentially think about a way to assert facts about it that gives you confidence that it works beyond the test that you can write for it. And so, yeah, that's it. I think I'm very early. Did I speak too fast? Probably. But thank you for taking the time. I hope you found it useful. I would appreciate, apart from the feedback for every talk that is useful, obviously weak points about this. Those are the things that I care about the most, because I do think there are. I hope I mentioned them more than anything else. And if you have experience with this, or if you can come up with different complementary things, please let me know. Because I kind of want to apply this a lot to the project I'm on, and if I do that and it doesn't work out, then I'm going to regret it. So if you can spare me from that, I would appreciate it. But thank you.
All right. Yep. One question.
Hi, thanks. Good talk. If you go back to the slide where you had the test with the default context,
This one?
Yeah, yeah. So what will happen here if you have the production stuff in your default context?
Yeah.
When when you send greetings, exchange in the future, and suddenly a new dependency is injected, or it starts requiring a new dependency.
Yep.
Then you will be calling the production stuff with this code, because you're only overriding the things you know about today. And when you add, say, I don't know, you have the Dropbox uploading thing,
Yeah,
then
so
suddenly will you start uploading stuff to Dropbox when you're running this test.
So that's true. Yeah, I don't have an answer to that. You're right.
I would just recommend have a test default where things just break if you don't have defined them.
Yeah, that could potentially it's an alternative that avoids that. So I'm just going to repeat what you said just to So the observation was that, let's say that in my implementation I add an extra bit and I don't update the test and that extra bit gets exercised here, then I'm screwed because potentially I can charge people. That's true. So the suggested alternative was that instead of having production defaults here, was to basically have things that error out, and that way, essentially, what you get out of it is that once you basically start, I'm going to extend on what you just said. Instead of having in production the default, you would have a production configuration here. That's actually a good improvement at that point. So making a distinction between the two. Ah, nice. That's nice. Thank you.
Thank you. Good talk. Thank you.
Thank you.
I don't have a question. It's more of a comment.
Yep.
You said you're looking for a name for this thing.
Yeah.
That name has been known for decades. It's called dependency injection.
Yeah.
And other languages have been doing that since forever. But I find it interesting that actually no one is doing that in Erlang and Elixir world. Almost no one. This was pretty eye-opening for me, for example.
So the thing that I see a lot of people doing is, let's see if we have. Don't know if I hope there's the internet on this computer because it's not mine. So this is the blog post I was talking about. Essentially, let me make it a little bit bigger. The one common way is this. Like that's the thing that I've seen the most, which is you build this at compile time. At compile time, you decide that this module attribute will contain essentially a reference to a module, and that's going to be passed. This is the most common way to do, or I don't know if it's called like this here. I don't remember, but you could call this an adapter pattern, right? You have it, but the adapter is solidified at compile time. More than once in my life, the fact that it's solidified at compile time became a limitation because you can't really, if you need to swap this at runtime, for example, let's say that if you had a delivery mailing system, you want to change, send this down, you want to change to Mailgun, you would have to write dynamic code anyway. And so you wouldn't be able to use that. So when you get in that situation, then what do you do? Because this is the problem. So this works really well for specific use cases where you have one singleton that you wanna swap around. So that's why it's a really good default. Most of the times it's fine. So you see a lot of this in the community, in a lot of examples and documentation and all of that. Apart from the fact that it's suggested by essentially the core team, and there's a good library for it that you can use for it, which is very lightweight and all of that. The other thing is that is because you have behaviors, then behaviors, to me, they somewhat hint. I don't know if that's a perception by people. When I talk to people about behaviors, they hint at static pieces of your code. You don't pass modules around because it looks a little bit different. And so that's despite the fact that if you use Gen servers and OTP, you pass modules around all the time. But it's true. It's true. It's not that common.
Yeah, but in, say, the language that should not be named world, you instantiate an object of that's configured in a way you want, and then you pass it on through the call stack. And then that is very, very common.
Yeah. So the technique itself, the technique is dependency injection. I should have mentioned that. What do you call the thing you inject? Then that's where I was struggling. Like you inject it, but what is it?
You inject dependencies.
I'm just not getting it. Yeah. Then dependencies.
Yes.
Sorted. Should have given this talk earlier.
Thanks.
Thank you.
All right. Anyone else? Super fast. All right.
Thank you.
Very much, Claudio.